Continuing with equivalent algebraic expressions, we're going to look at adding and subtracting rational expressions, and we should be able to state values that make that expression undefined. Match the expression with its restrictions. We have a restriction when we divide by 0. So anything that is in the denominator, if it is equivalent to 0, that is undefined. So we need to figure that out. So in the first case, x can't equal 3. So that would be here, because if x was 3, this would be 3 minus 0, 3 minus 3, which is 0, and we cannot divide by 0. In the second case, x plus 3 can't equal 0, so x can't equal negative 3. And finally, the last case, the bottom, x minus 5 can't equal 0, so x can't be 5. So that's the top one. To add and subtract rational expressions, we must first recall how to add and subtract fractions. In the first case, we have a common denominator. And so when we have a common denominator, we keep the denominator and we subtract the numerators. So it becomes 5 minus 1 over 7, or 4/7. In the second case, we need to find a common denominator. We have a 3 and a 4. So we need to ask ourselves, what does 3 and 4 both go into? That would be 12, or 3 times 4. So in order to do that, I'm going to multiply this side by 4 and this side by 3 in order to make the 12. What I do to the bottom, I need to do the top in order for it to be equivalent. So that needs to be multiplied by 4, and that needs to be multiplied by 3. So rewriting that, I have 4 over 12 plus 9 over 12, which equals 13 over 12. So the goal is to find the common denominator and then add the numerators. Let's use this skill to add and subtract rational expressions. In the first case, we have a common denominator, so let's rewrite it. Simplifying this, we have 3 minus 1 over 5x squared, or 2 over 5x squared. Keeping in mind that the denominator cannot equal 0, so then 5x squared can equal 0, which means x can't equal 0. Let's move on. Reviewing from the last page where we're adding regular fractions as opposed to more complicated rational expressions. I just want to go through the process once again. In this first step, we needed to find a common denominator. So 3 and 4 both go into 12. That's going to be my common denominator. To make this a 12, I need to multiply by 4. To keep this equivalent, I need to multiply the top by 4 as well. Similarly, I need to multiply this one by 3 and its top by 3. So I get 4 12s plus 9 12s equals 13 12s. So with that process in mind, I'm going to come over and do the same thing. I need a common denominator for x and x plus 1. Here it was 3 and 4. X and x plus 1 could be 3 and 4 as well, but we don't really know. So we're going to call it x and x plus 1. Notice that I took the 3 and multiplied it by the 4, and I took the 4 and multiplied by the 3. I'm going to do the same thing here. So I'm going to multiply the x by x plus 1 and the x plus 1 by x. That way I'll have a common denominator. Both denominators have the x and the x plus 1. Naturally, to keep it equivalent, I need to multiply the tops by the same thing that I multiplied by bottoms. So rewriting that, I get x plus 1 over x times x plus 1 plus 3x over x times x plus 1. Combining that, I get x plus 1 plus 3x all over x times x plus 1. Simplifying, I get 4x plus 1 over x times x plus 1. The last step is to state the restrictions. So again, looking at the bottom here, x times x plus 1, therefore x cannot be 0 and x plus 1 cannot be 0, which means x cannot equal negative 1. So our two restrictions are x cannot equal negative 1 and x cannot equal 0. Example 3, getting a little bit more complicated. First thing is that we need a common denominator. Right now it's 4 over 3x minus 2 plus 6, and this would be over 1. Our common denominator would just be the 1 and the 3x minus 2, so I guess if we were to multiply those. Keeping in mind that if I multiply the bottom by 3x minus 2, I need to multiply the top also by 3x minus 2. Okay, so following it through, multiplied the top and bottom by 3x minus 2, and I end up with this. Using the arrows, the expand 6 times 3x and 6 times 2 gives me 18x minus 12. Again, that's over the common denominator of 3x minus 2, so I'm going to combine the two numerators. 4 plus 18x minus 12 gives me minus 8 plus 18x over 3x minus 2. Last step, state the restrictions. Okay, so the restrictions, I set up the denominator, which is 3x minus 2, is not equal to 0, and solve the equation, so x cannot equal 2/3. Okay, in this case, I have 3 over x plus 1 plus 4x over x squared minus 3x minus 4. I do need a common denominator, but I'm going to factor this expression first, this trinomial first. Okay, so factoring x squared minus 3x minus 4, I get x minus 4 times x plus 1. Now I'm going to find the common denominator. You notice that they already have the x plus 1 in common, so this term needs an x minus 4. All right, so I'm going to simplify this using 3 times x and 3 times negative 4. I'm going to combine the numerators since we now have a common denominator. I'm going to simplify. So in the end, I end up with 7x minus 12 over x plus 1 times x minus 4. And I need to write the restrictions. Okay, so x plus 1 can't equal 0, so x can't equal negative 1, and x minus 4 can't equal 0, so x cannot equal 4. Okay, on to the next page. Last example for today. Looks pretty complicated. The first step is to factor all of these trinomials and see what happens. Okay, so in each case, with each trinomial, I've factored two numbers to add to 2, multiply negative 35, I get x plus 7, x minus 5. Similarly for each of these other trinomials. So hopefully you can double check my work. All right, so now we always, of course, need to follow BEDMAS. BEDMAS is important in everything we do. So we need to do division and multiplication before we do addition and subtraction. So I'm going to look at this part of my question right now. We need to keep in mind that we can divide common factors from both the top and bottom. So anything that occurs on the top and bottom can be canceled out. And by canceled out, I mean x plus 4 divided by x plus 4 is 1. X minus 6 divided by x minus 6 is 1. And so I can cancel some things out. So x plus 4 and x plus 4, x minus 6 and x minus 6, x minus 3 and x minus 3. So all I'm left with in this section is the x plus 2 over the x plus 5. So rewriting this line, including the front, I have x plus 1 over x plus 7 times x minus 5, plus, then I did this whole multiplication here, I end up with x plus 2 over x plus 5. So there we are. Now I need a common denominator. To set up a common denominator, this denominator needs an x plus 5, so I'll multiply top and bottom by x plus 5. This denominator has the x plus 5, but needs the x plus 7 and the x minus 5, so I've shown that in green, top and bottom. Okay, so the last step then is to expand and simplify and then state the restrictions. All right, so this one got kind of ugly. I expanded these two expressions, so x plus 1 times x plus 5 gives me x squared plus 6x plus 5, and I started to expand this, and I ended up with this ugly expression over here. Once I collected all my like terms on the top, this is what I ended up with. So my last step now is to determine all of my restrictions. Now the problem is when you're determining restrictions, you have to consider every single time something was in the denominator. So we have to go back to the second row up here. So there was an x minus 6, an x plus 4, an x plus 5, and an x minus 3 all in the denominator. I need to make sure that all of those, oh, and an x plus 7 and an x minus 5. So I need to make sure all of those are restrictions. Even though at this point all we have left are these ones, it doesn't matter. At one point these were in the denominator, so I need to take them into consideration.